Good evening, everyone. My name is Troy Feener. I am a Dansha in the Canadian Chiruryo Karate Association. I hold the rank of Yondan Shihan. I train in Calgary at the Calgary Chiruryo Karate Club under the head instructor there, Dr. Andre Gure. I call him doctor because, first of all, he is one, PhD in pathophysiology of disease. I first met him in my undergraduate studies at the University of Calgary, where I was taking science, biology, with a major in zoology. I then did my graduate work with him as well, where I studied ecology and parasitology. And since then, I have more or less been running research labs at universities across Canada. My current lab, I manage researchers about chemistry of infectious diseases, developed new technology there. So that introduction is by way of explanation as to why I am talking about something in a presentation form, because that is what I know. I could have done a demonstration on karate, but honestly, there are people here who know more than I will rather have forgotten more than I will ever know about karate. But I do know about research, and I do know about structuring research presentations in a way that hopefully is informative and teaches. So tonight I'm going to be talking to you about stretching, and in particular what the current science says about stretching. The talk will go over basic introduction, why we would even want to stretch, what are the structures we're stretching, what happens to those structures when we stretch them, what does that mean in karate, what are the types of stretching that currently in practice, and what are the benefits and disadvantages of those types of stretches, and then I'll follow up with a summary. First, let me, there we go. So first, let me say there is a disclaimer here. Everything I am about to say has a 10-second guarantee. This is because I am not a sports physiologist. That is if I were to trust anyone on the topic, I would say a sports physiologist, a physiotherapist, orthopedic surgeon, someone who's in rehabilitation of sports physio. I would trust their judgments more than I. What I'm going to be showing you tonight is my efforts of doing a cursory review of literature reviews. So basically people who have looked at all the researchers in particular who have looked at all the current body of evidence and summarized them in a single paper. That for me is the low-hanging fruit when I'm trying to learn on a new topic. So again, I am a student right now learning about this, and that is why I give you a 10-second guarantee. I'm going to start at the beginning where I learned about stretching, and that was in my school gymnasium from people who were not experts, but they were teachers, gym teachers. Most of them were gym teachers second, and probably English or math teachers first. My first real sport athletic endeavor was in track and field. I was a small, short kid. I did not do football. I did not do volleyball or basketball. I did track and field because I was fast. And my track and field coach happened to be my English teacher. And as such, I got the coaching from him that he got when he was in school. So it was not what I would call current and up to date. So the old school method of stretching before you exercise was primarily based on static stretching and static stretching alone. Expanding on this by what I saw on television wasn't really that much more informative or helpful. I didn't exactly have a great education on why to stretch, how to stretch, and Certainly watching the Olympics didn't help, but I did get a lot of really good useful information from Bloodsport. This leads me to the question that as a scientist is always where I start off is why do we even bother doing something? And in this instance, why do we stretch? Mostly, I wouldn't have expected our ancestors to stretch, you know, having a little warm up before they go out and hunt a mastodon, or you know, hunting and gathering or whatever they're doing was not something that I think they had to do. But we are no longer ancient man, and I would say in the last 100 years, we've really changed from a more sedentary, a more hunter-gatherer lifestyle or horticultural based lifestyle. And so our sedentary lifestyle has really changed the way our bodies have been shaped. Humans are plastic, which basically means that we adapt and we mold into the situation that we see the most. I sit at my desk every day. Sometimes I stand at my desk every day, but by and large, I don't chase down animals. I don't climb trees. I don't squat and pound grain for hours on end. I sit at a chair with my knees at 90 degrees and my waist at 90 degrees and my body hunched over. And so the plasticity that is inherent in my body, it gets rid of what it doesn't need. It doesn't need long hamstrings. It doesn't need flexible hips in this position. So to be efficient, our body just molds itself and remodels itself to fit what the use is. Also, we live a lot longer than our ancestors did. So as a result, I think if we want to have a good quality of a long life, stretching is a necessity to keep ourselves mobile. If I didn't stretch on a regular basis or was active on a regular basis, my life later would be much less comfortable. And so, you know, we're not hunting down game, but we are forcing ourselves to do activities that are, I would say, mimicking those early man activities, and that is through competition. You know, it's no longer survival of the fittest, but it is a competitive. There are competitive activities that we engage in. Mankind has adopted a lot of sporting activities, as well as things that we do recreationally for our own betterment. And that is really the reasons I come up with to stretch. The what we are stretching is a little bit more complicated. And so I'm going to dig into my physiology and anatomy background from zoology major and go through a bit of a very cursory, shallow view of what we are doing, what we are stretching, what's involved. And this is, there are going to be people in this group that know more about this than I do, or am presenting. But this is an introductory presentation meant to give everyone a working understanding of what's going on. The term I use in my work when I'm trying to explain things that could be complex is I use the grandma ocular method. If I can show this to my grandma and she can see it and understand it, then I've done my job well. So that's what I'm going to attempt to do tonight. So I'm going to talk about the joints, the ligaments, the tendons, the muscles, and the neuromuscular system in particular. Let's talk tonight. So first off, joints. Joints are where we as humans, mammals in particular, not just mammals, but vertebrates in particular, really have evolved to move. So they are what make movement possible. Anytime you have an articulating two bones that articulate, they come together, that is a joint, bone to bone, two bones coming off, at least two bones. There are joints that are made up of more bones than just two. And they really just enable movement, the ability to walk. We are endoskeleton creatures as opposed to insects that are exoskeleton creatures. They form the same function. They give structure to the motor, which is the muscles. The joints also limit our functional and physical range. So there are some joints that are more mobile and more planes than others. Some only work in one direction, some work in all directions, but every joint has a specific range of motion. And that range of motion is dictated by the structure of the bones and how they interact with one another, as well as the soft tissues that connect them. Here I'm showing you a hip bone. And these, I'm showing this because it's important to understand that anatomy is not uniform. Not everybody has the same anatomy. Not everybody has the same structures. So in this case, it's showing here the different femur head shapes and angles of the femur heads, which will affect the range of motion of the individuals who have this one versus this one. So while the hip is designed to do one thing, there is variability within those structures based upon the bone shapes themselves. Ligaments are soft tissues. They are collagenous connective tissue that are very strong in one direction. They make up and they connect generally two bones, so one bone to another bone. And they protect the bone from separating from each other during its activity and its motion. I'm showing here the ACL and the PCL of the knee. You can see the meniscus at the bottom. A lot of people get torn meniscus or menisci. This is the femur head, and this is the tibia and the fibula. Here we've got the ACL and the PCL, and these are ligaments that connect the two bones together. And if it allows motion in this linear plane, but it prevents motion in this direction. So you don't see the femur going one way and the fibula and the tibia going the other way. And that is due in part from the connection of the ligaments. So they hold the bones together as a primary structure, almost like a tie-down rope, if you will. Next, we have tendons, and tendons connect muscles to bones. So usually there's only a single muscle connecting to a specific site on a bone, but sometimes you will have muscles that will connect to multiple different bones. But generally speaking, the simplest case is like the calf muscle, the gastrocnemius, that goes down, and it will connect to the heel. Gonna go back. It will connect to the heel here. And so when the muscle of the calf contracts, this is the tether point that pulls the heel bone up and flexes the toes down. So tendons in general are similar in structure to ligaments, but they differ in that they connect the bone to a muscle. And they are continuous with the sheath of the muscle, which is, many of you have heard of fascia. It's very, there's lots of science and pseudoscience out there about fascia right now. I'm not going to cover fascia today, but just knowing that the tendons are continuous with fascia in general, and that fascia do make up a structure, but I'm not going to talk about those today. And the driver of all motion, generally speaking, is muscles. There's three kinds of muscles in our body. The three types are skeletal, smooth, and cardiac. skeletal muscle is the one I'm going to talk about here today. The other two, cardiac, obviously, heart, and smooth muscle. So your digestive tract is made up of smooth muscle. Your veins and arteries have components of smooth muscle as well. But here is the structure, and it is a structure of decreasing ropes, if you will. So if you can think of one big muscle, say it's your bicep muscle, that muscle has within it strings of threads, and these threads have even smaller threads that make up a single muscle fiber. And inside this muscle fiber are threads of cells. Now, move this, you can see here, these are made up of individual cells, and these cells are sort of broken up into structures called sarcomeres. And sarcomeres are, they are protein structures that sort of mesh together like this. They're actin and myosin. So you can see here one structure, this thin green one is the actin, and the red one is the myosin. Those are terms that you'll hear. But they interact like this, and they can pull each other in, and what that does is it shrinks the length of the muscle itself. And the reason I'm describing this is because will be important later on when I talk about stretching and what it does to stretching. But generally speaking, skeletal muscles are under our voluntary control. So that means that we consciously decide to do something with them. That doesn't always, it generally is voluntary, but there is involuntary responses for your muscles. You know, when you get hit by the hammer on the knee patellar tendon, your heel will swing up. That's an involuntary response. And we'll talk a bit about that later. And that later is now. The neuromuscular system is intimately integrated with this concept of stretching and flexibility as well. Mostly, you know, most people think of the neuromuscular system as the nerves that send the signal from the brain down to the leg, tells it to kick, does the things it needs to do. But it's incredibly complex system of controls and pathways that have been built into your brain. But there's also a fail-safe built into the system. It's this nociception. So basically in your tendons generally, there are receptors. These are stretch receptors. So when the tendons start to feel stretched, like down here at the bottom of the muscle, and there's a stretch, nerves that are stuck in there, they send a signal back to the spine here. And instead of going all the way to the brain and then back, it just comes right back to the muscle and signals it to contract. That contraction is a fail-safe mechanism. If the muscle is getting stretched to the point where it could potentially injure the joint, a reflex will be automatically stimulated to contract the muscle to prevent that from happening. That is a good thing, so that we're not, you know, breaking our joints all the time. But it does represent a challenge when it comes to stretching, because if we don't have adaptation of this muscle in being stretched very often, then this response is quite sensitive, and it requires some work to desensitize it and adapt it for it to be in a stretch position. I'll talk a bit more about that later. So the neuromuscular system is an essential part of this whole stretch topic. So what does stretching do to all these structures? So I've talked briefly about the neuromuscular system and the nociceptive adaptation. That is, so when you stretch something on a regular basis, you become adapted to the stretch. It's a tolerance, if you will. You begin to not feel the stretch. Your pain receptors are desensitized. Less danger signals are going off in your body because of the stretch that's happening. And that is what's happening when you do a lot of stretches on a consistent basis, or you're using, like if I'm out in the garden and I'm squatting down, or if I have a trade that involves me, squatting down and working close to the ground, or if I sit cross-legged a lot, it becomes more adapted, and that a lot of the time is due to the neural adaptation. Your muscle is still being stretched, just like it would be if you weren't used to it, but because you're used to it, your brain is not telling you it's a warning. There's also a portion of tendons, some ligaments, but not so much, and muscles a little bit as well. Viscoelasticity. This is, I'll be honest, I don't know a whole lot about viscoelasticity, but generally speaking, it's when your tendons change structure so that they can be longer. There is more elasticity and less tension in the tendons themselves. So that's what's happening when you stretch. There's also the ability of your muscles, when they become stretched on a regular basis, to basically, I talked about plasticity earlier, they basically become longer. So they add more of those structures. So if your muscle has a million of these in a row in series, if you add another 100,000, your muscle is going to be longer as a result. And that will be an adaptive process that happens as you stretch on a regular basis. So why do we need to stretch in karate? Like I said, we are playing at challenging our bodies, at survival of the fittest. We are doing things that are physically demanding for recreation or for self-defense or for whatever your motivations are. But we go from our sedentary lifestyles to the dojo, and all of a sudden we have to kick, punch, block, step, jump, throw, fall, all of these things. And so we have to prepare our bodies to do that. And stretching is an effective way of doing that. It's not just for flexibility, it's also for injury prevention. I'll talk a bit about that shortly. But our flexibility, as many of us know, does limit what we can physically do. I mean, Soroka Sensei here doing this kick to someone's head, I can't do that. I couldn't do that when I was 20. I can't certainly do that today. But it's possible to do that. And flexibility is an important aspect of why we need to stretch. So we also know from karate that our target dictates the technique we choose. So, I'm not going to hit someone in the chin with a nukite. I'm going to use a fist. Well, it's the same thing with stretching. So we stretch for a few reasons. We stretch for flexibility. We also stretch for performance and speed. And there is definitely an element of stretching in practice to improve recovery from the work that we do. that was a controversial topic for many years, but I think the science is, we will see later, is the science is there. So we stretch for different reasons, and we use different stretches for those reasons, as you'll see here. So there's basically 4 types of stretching in practice today. The one that I talked about earlier, that all of us probably learned in school, is static stretching. We go to the edge of our range of motion when it starts to hurt and become uncomfortable, and we hold it, and we hold it, and we hold it, right? I mean, I was under the impression that we would have to hold something for 20 minutes in order to see a change in flexibility. I mean, I believed that probably up to about 10 years ago. There's also dynamic stretching. So dynamic stretching is more functional, I would say. It's using the range of motion that we've got and trying to expand that range as we move through it. So we're not standing still or holding the stretch. We are moving through our full range of motion, and we're pushing it each time we do it. Ballistic stretching is another stretch, and I still do this. I do it myself. I teach it myself. I experience it myself. These ballistic stretching motions, leg swings as high as you can. That's a ballistic motion. What we're doing is we're generating as much speed and pressure, trying to force that muscle, the tendons, into a position where they have experienced an extreme amount of strain and stretch, but not so much that you injure yourself. I'll talk a bit about that later. The 4th one I'm going to talk about is one that it's very effective, but it's difficult to do alone. Proprioceptive neuromuscular facilitation is the long term, PNF. Basically, if you've got a muscle or a limb, let's say you're lying on your back with one leg straight, and a partner is taking your other leg and stretching it upwards. So it's a hamstring glute stretch. To apply PNF in that situation would be your partner would get you to a point where you feel the stretch, they hold it for 20, 30 seconds, and then you would actively isometrically, meaning the muscle doesn't change length, you would isometrically push against your partner. So you're using the muscle, you're expending energy in the muscle, and then you relax after 20 or 30 seconds, and your partner extends the stretch a little farther. And you do that in cycles to increase your range of motion. And that's a very effective way. So those are the 4 basic ways. I'm also going to mention here that there is acute and chronic stretching. Now, most of us do understand these acute and chronic terms in forms of disease, like acute forms of asthma, or chronic asthma. It basically just means something that happens very suddenly and goes away. That's acute. Or chronic, it lasts a long time. You do it on a regular basis. So you'll hear me talk as I go through about acute versus chronic types of stretching. So which one of these is best for flexibility? Remember earlier I said that we will use a different technique depending on the target. So if our target is flexibility, we want to increase our range of motion. The research is actually pretty consistent. So no longer do we have to hold our stretches for 20 minutes, half an hour. What's more important is consistency and frequency of your stretching. So here is a great YouTube video that teaches this very well, and it's based on science. So he goes through 32 different studies parses out all the information and presents it in a way that is really concise. So he breaks it down by week. If you do 6 sessions of 3 sets, 30 seconds for each stretch, equals 9 minutes a week total. That is the optimal amount of time for the maximum amount of range of motion increase or flexibility. An alternate way, which is equally as effective, is 3 sessions, 3 sets, 60 seconds each stretch for a total of 9 minutes per week. Now this is per stretch. So if you have multiple different sets of stretching, you have one stretch for side splits or one for front splits. That would be 18 minutes total time per week if you combine them. So this is based on the most current research, and what stretching works best is static stretching and PNF. Dynamic stretching and ballistic stretching aren't as effective when combined in this sequence and sets as static stretching and PNF. Now, the difference between static stretching and PNF holds a small advantage, but not very many people have partners to help them stretch all the time. And PNF is difficult to do without a partner often. So generally speaking, if you were to do static stretching, it would be nearly as equivalent as PNF as far as your gains. But the key here is chronic. I've got here 5th one, foam rolling, just for shits and giggles. The research isn't really clear. It doesn't involve, some myofascial release and things like that. I don't think there's really consistent research. I haven't found any yet. If anyone has, let me know. But I just mention it here because there's probably some people who are asking, well, what about foam rolling? Foam rolling is more just manual massage. But there is a component, I think, of myofascial release, which maybe could be attributed to increased mobility, range of motion. So many of you who have been in competitive environments will have heard that static stretching is bad. So, because there's so many studies over so many years that have shown that static stretching as well as PNF have been shown to decrease your performance, your strength, your speed. And so, it's going to kill your gains. So that was very much a common perception because of these studies. But when the studies get analyzed in detail, it becomes clear that these studies talk about doing a static stretch, holding it for an extended period of time. Some of these studies have held them for like 20 minutes. Most of them are over 90 seconds. And these are not recommended times. So it's not a realistic environment or a realistic test. Also, many of these studies take the participants from a static stretch directly into performing their activity. And that is not also a realistic situation. I don't know many of you who hold a static stretch, and then, if you're in a split and you're holding that for 30 seconds, and then you get up. I know I am not at my best right after a long stretch like that. But, and that's not a realistic situation. So when these types of stretches, particularly static stretches, are performed in real situations, and the studies are done that way, the performance losses are gone. So if you integrate a static stretch and you hold it for 30 seconds or 60 seconds, and then you move on and it's part of your warm-up or part of your cool down, static stretching does not decrease your performance, doesn't decrease your strength, doesn't decrease your speed. So just this is a great video by the same guy that did the other one, and he really goes through the research and parses out the different types of studies and what they're actually testing, and it shows it pretty clearly that static stretching is effective if it's part of a warm-up that has dynamic warm-up activities that warm up your muscles, and they're not in isolation. So this is sort of what I've talked about already. This is a good review that's recent. So this one's from 2018, that's fairly recent in terms of this kind of research. The evidence clearly shows in these reviews that chronic stretching, whether it's static stretching or dynamic stretching, or any of the other stretching for that matter, does reduce the risk of injury if it's done in a chronic way. So if you do it on a regular basis, it will reduce the risk of injury. It also increases performance if done chronically as well. Only if you're stretching for long periods of time, over 60 seconds, and if you don't incorporate it into a warm-up. Chronic stretching still benefits everyone, whether you're an elite athlete or a person like, general population likes to run on the weekends, does martial arts. But increasing the intensity, the volume, the duration, or the frequency does decrease acute performance immediately after. So if you keep that in mind, that would be where you're setting yourself up for potential injury. If you're working this into your warm-ups and you're going straight from a static stretch into a kata or into a kumite match, that is where you have a potential risk for injury or decreased performance. So what about DOMS? DOMS means delayed onset muscle soreness. So that's an acronym for delayed onset muscle soreness. This is the muscle soreness you feel after a really heavy workout. And it's usually not the next day. It's usually, 24 to 48 hours after the actual workout. Lots of conflicting opinions out there about DOMS. But most of the conflicting research was done much earlier, so we're talking 20 years ago, and the research quality was not that great. They were usually only using a single bout of stretching before and or after a workout, and then they would measure the DOMS of all the participants. And that showed inconsistent and contradicting results. More recent research and studies have shown that if you do consistent chronic stretching before and after your workouts, but on a regular daily basis, that it does help prevent injuries and, as we know, but also reduces the DOMS, the delayed onset muscle soreness. But this is a reason, I think, to motivate some people to do stretching, but some people don't actually ever feel delayed onset muscle soreness because it's often quite genetically variable. So some people do feel it, and some people don't. I wish I was one of those that never felt it. But that is not the case. So that's more motivation for me to definitely stretch more consistently than I do. So I don't walk around and hobble around after a workout after summer camp. So that's my talk for today. I'm going to summarize it very, very briefly. Most effective stretching you can do is static stretching and PNF. It does increase flexibility, range of motion, decreases your risk of injury. It can also help you with delayed onset muscle soreness if you have that. It should be included as part of a dynamic warm-up, meaning that there are other range of motion exercises that are sport specific. Ballistic stretching is the least effective of all the four. There actually is some research out there that indicates that ballistic stretching is contraindicated in some activities. I'll leave that there. Not gonna state much more than that. And it's static, dynamic, PNF, any stretching does not impair your performance unless you immediately jump out of your stretch and perform your sport or your activity immediately. So that is my talk. I hope you enjoyed it. If you have any questions, throw them in the comment. Thank you for Sensei Giffen for making this forum available to everyone. It's very much appreciated by me, especially during these COVID pandemic madness times. Yeah, thank you very much. Obrigado, gozaimasu.